In the beginning, there was no green, no sky, no sound, only the silent collapse of dust and fire drifting in the newborn galaxy's glow. The Milky Way, still young and restless, carried in its swirling arms the remains of stars that had lived and died long before time had a name. From their ashes came everything: hydrogen, carbon, iron, the alphabet of existence, scattered through space, waiting to gather again. 4.5 billion years ago, a cloud of gas and debris began to turn upon itself, gravity pulling it inward with patient insistence, until in the heart of that spiral, a star ignited: our sun. Around it, rings of cosmic refuse shimmered, colliding, melting, reforming, a storm of rock and ice and metal, each fragment a seed of a future world. From that storm, the third orbit from the sun began to thicken with weight, accreting more of the dust, enduring impact after impact. It was not yet Earth, but a molten sphere, a glowing wound in space. For tens of millions of years, it was bombarded by planetesimals, wayward fragments of the solar nursery, each collision releasing energy so fierce it kept the surface in an eternal fire. Volcanoes were not yet mountains. They were the veins of the world itself, bleeding magma into the void. Then came an impact beyond imagination. A wandering body, roughly the size of Mars, struck the proto-Earth with a violence that nearly tore it apart. The shock liquefied rock, vaporized oceans that did not yet exist, and cast a halo of molten debris around the planet. From that incandescent ring, our moon was born, a companion forged from shared ruin. The newborn Earth spun faster then, days lasting only 5 hours, tides enormous and wild, the moon circling close enough to fill half the sky. As the planet cooled, its surface began to harden, a crust forming over the glowing mantle beneath. Yet the crust cracked, shifted, and remade itself endlessly. Steam hissed from fissures, carbon dioxide filled the air, lightning flashed across methane clouds. There was no oxygen, no blue in the heavens, only the dense murk of an atmosphere shaped by fire. Comets, bearing ice from the outer reaches of the solar system, fell upon this hell, their frozen cargo melting upon impact, giving the planet the first whispers of water. Gradually, as millions of years passed, those waters gathered, not as tranquil seas, but as boiling pools beneath a sky thick with ash. Rain fell for centuries uncounted, cooling the crust, flooding the lowlands, filling basins. Oceans were born. In their depths, minerals dissolved, chemical soups stirred by undersea vents rich in heat and metal. It was in such crucibles that the first improbable spark of life emerged. No witness marked that moment, no sound, no movement, save for molecules aligning in patterns that learned to copy themselves. It may have taken millions of trials, failures upon failures, before the first true cell appeared. Fragile, blind, persistent. These earliest microbes thrived in darkness, feeding on the minerals that oozed from the planet's wounds. They did not yet breathe oxygen, for oxygen was poison to them. Instead, they found energy in the chemistry of the earth itself, in sulfur, iron, and heat. The world they inhabited was alien. Continents unformed, skies tinted orange, seas green with dissolved iron. The moon loomed close and massive, tugging at the tides, slowing the planet's rotation bit by bit. In that endless rhythm of rise and fall, of heat and chill, life multiplied invisibly, tracing its history not upon land or air, but within the quiet persistence of molecules. Then came a revolution that no creature could see, but that would alter the fate of all who followed. Some of those ancient microbes learned to capture sunlight. Using it, they began to split water molecules, releasing oxygen, a waste gas to them, a miracle for us. For eons, the oxygen they produced reacted with the iron in the seas, staining the sediments red, forming vast layers of rust that today form our oldest rocks. Slowly, the poison became a promise. The Great Oxidation Event had begun. The skies changed. The orange haze lifted, replaced by the pale blue of scattering light. The seas turned clearer. The land, still barren, was lashed by wind and acid rain. Lightning struck endlessly, shaping and reshaping the chemistry of the atmosphere. Above it all, the moon receded, retreating inch by inch, its gravitational pull still sculpting the ocean's rhythm. Beneath the waves, the architecture of life grew more complex. Cells learned to cooperate, forming colonies that became organisms, organisms that developed nuclei, internal structures, and energy factories, mitochondria, once free-living bacteria, now enslaved by evolution's bargain. The Earth, which had once been a world of stone and fire, became a planet of carbon, protein, and purpose. Continents drifted on molten foundations, colliding and separating over spans of hundreds of millions of years. In the Archean Eon, the first proto-continents like Valbara and Ur rose from the seas, their jagged coasts battered by storms unending. Volcanic arcs and oceanic ridges remade the planet's face as tectonic forces pulled at its crust. Through it all, life adapted, not to stability, but to change itself. By 2 billion years ago, oxygen filled the atmosphere enough to reshape the chemistry of oceans, allowing new forms to arise that could harness it for energy. The surface of the planet froze and thawed in cycles, the first great glaciations sweeping across continents. The Earth became, at times, a white sphere in space, encased in ice from pole to equator, reflecting sunlight back into the void. But beneath the frozen crust,
hydrothermal vents still pulsed with warmth, a refuge for life in exile. When volcanic carbon dioxide accumulated again, the ice retreated, the planet thawed, and new possibilities emerged. The Earth, once a molten ember, now breathed in epochs. It shifted between extremes, heat and frost, calm and cataclysm, each cycle giving rise to new beginnings. Around 600 million years ago, in the late Precambrian, life took a leap that would echo forever. Multicellularity became the new language of survival. Soft-bodied organisms bloomed in shallow seas, strange forms without bones or shells, their imprints preserved in stone. The Ediacaran biota, Earth's first visible life.
They were followed by the Cambrian explosion, a sudden flourishing of diversity beyond imagination. Creatures with eyes, shells, limbs, and teeth appeared in a geological instant, exploring the possibilities of form and motion. Trilobites scuttled across the seafloor. Predatory worms hunted through silt, and coral ancestors built the first reefs. The seas shimmered with color and motion, an underwater empire of experiment. Yet the land remained empty, save for wind and rock. For hundreds of millions of years, Earth's continents were barren, lifeless expanses, where only lichen-like mats clung to damp stone. Slowly, mosses and simple plants crept outward from coastal margins, learning to anchor themselves in soil made from the grinding of ancient mountains. With them came the first insects, small and tentative explorers of this unclaimed domain. The sky, long silent, now carried the rustle of wings. Volcanoes exhaled, mountains rose, and continents drifted together into a single vast landmass, Pangaea, surrounded by a global ocean. The pulse of life quickened. Amphibians crawled from water to land, their lungs tasting air for the first time. Reptiles followed, hardening their eggs against the dryness of the world. Forests spread, dark and humid, their decay trapping carbon in layers of peat that would, in time, become coal. Oxygen levels soared, and insects grew to monstrous sizes. Dragonflies with wingspans of half a meter ruled the swamps. But the earth is a patient sculptor and an impartial destroyer. Periods of flourishing are always followed by silence. The Permian extinction came, the Great Dying, when volcanic outpourings in Siberia poisoned air and sea, raising temperatures and choking oxygen from the oceans. 90% of all species vanished, leaving behind a planet gasping for renewal. From that ruin, the age of the dinosaurs began. From the silence of extinction rose the age of giants, and Earth, patient and unbroken, set the stage anew. In the wake of devastation, the survivors were few: small reptiles, scattered plants, and creatures that crept through the cracks of catastrophe. Yet from these remnants, life began again to weave its intricate pattern. The continents joined as Pangaea, baked under unrelenting sun and monsoon, a supercontinent where deserts stretched for thousands of miles. But deep within its heart, Tectonic forces whispered rebellion, tearing at its seams, birthing fissures that would one day become oceans. In this restless world, dinosaurs emerged not as monsters of chaos, but as the inevitable children of adaptation. They were not the first to walk upright, but they mastered the art of endurance, evolving into forms of astonishing diversity. Some thundered upon the plains, their massive limbs shaking the earth. Others glided through forests or hunted beneath ferns taller than trees. The air grew warm and thick with oxygen, and ferns, cycads, and conifers covered the land in endless green. Volcanoes still roared in the distance, yet their ash fed the soil, and the cycle of destruction and renewal continued.
The Triassic gave way to the Jurassic, and the world transformed again. The great supercontinent split apart. Pangaea fractured into Laurasia and Gondwana, and with that fracture came oceans, climates, and new frontiers for life. Dinosaurs multiplied in kind, long-necked sauropods lifting their heads like moving towers against the canopy. Carnivores sleek and calculating, feathers whispering across their arms long before the notion of flight was born. The first birds took to the air, descendants of predatory lineages that had learned to dance with the wind. The sky became a second ocean, alive with beating wings. Meanwhile, in the seas, life pursued its own empire. Ammonites coiled their shells in perfect spirals, their geometry echoing eternity. Ichthyosaurs glided like living torpedoes, and coral reefs expanded, their polyps building cities of limestone. Beneath the surface, microscopic algae filled the waters with invisible abundance, feeding the web of life that would one day shape the chemistry of the air. The continents drifted further apart, and with their movement came storms, currents, and the endless sculpting of coastlines, every tide a stroke of time's hand. The Cretaceous brought splendor and fragility in equal measure. Flowers bloomed for the first time, their colors an invention of seduction, their scents a language older than speech. Bees appeared to answer them, shaping the symbiosis that would one day feed humanity itself. Forests filled with angiosperms, the flowering plants that turned Earth into a gallery of light and color. The planet grew warmer still, polar regions lush and teeming with life. But even as it flourished, the seeds of its next reckoning were sown far beyond the sky. 66 million years ago, a visitor approached from the dark, a fragment of stone 10 kilometers wide, traveling faster than thought. It struck near what is now the Yucatan Peninsula, and in an instant, the world was unmade again. The fireball vaporized oceans, forests burned from pole to pole, and the sky darkened with soot for years. Photosynthesis ceased, ecosystems collapsed. The reign of the dinosaurs, which had lasted for over 160 million years, ended in the space of days. Only the smallest survived, the ancestors of birds, the mammals hidden in burrows, the seeds buried beneath ash. From that silence rose a new kind of world. Mammals, once nocturnal and insignificant, ventured forth into the vacant niches left by the fallen giants. They grew, diversified, learned new forms, hoofed runners upon grasslands, primates among branches, whales returning to the sea from which their ancestors had fled. The continents continued their slow dance. Gondwana shattered into fragments that became Africa, South America, Antarctica, and Australia. India, a wayward island, raced northward to collide with Asia, lifting the Himalayas toward the heavens. The planet's surface became a mosaic of movement, and in its shifting crust lay the key to climate and life alike.
Grass appeared, a quiet revolution that remade the planet. The spread of grasslands transformed the balance of ecosystems, fostering herds of grazers and predators to chase them. With each blade, the earth drew carbon from the sky, cooling the climate, refining its atmosphere once more. Rivers carved plains, winds carried seeds across continents. The biosphere became a vast engine of exchange. In the forests of Africa, small primates descended from trees to walk upright upon two legs, their hands free to shape the world. These early hominins did not know they were heirs to epochs. They gathered stones, learned to strike sparks, and in doing so, joined the chain of cosmic creation that had begun in the dust of dead stars. Fire, once the terror of forests, became the servant of thought. With it came warmth, protection, the power to transform raw into cooked, darkness into light. Around those fires, under skies dense with constellations, the ancestors of humanity began to dream. Earth watched silently as glaciers advanced and retreated, as ice sheets grew and melted in cycles tied to the subtle dance of its orbit and tilt. The Pleistocene came, and the face of the planet changed again. Vast ice caps covered continents. Mammoths and mastodons roamed beneath auroras. Steppe and tundra reached where forests had once thrived. Humanity, the newest actor on the ancient stage, began to alter the rhythm of the planet itself. They tamed rivers, planted fields, built monuments of stone to echo eternity. The rise of agriculture 10,000 years ago transformed ecosystems as surely as the asteroid had done before. Forests fell, soil turned, species vanished or multiplied at human will. Yet even then, the planet continued its own cycles, indifferent and enduring. The magnetic poles wandered, continents drifted, volcanoes whispered beneath the seas. The air we breathe today is not the air of the ancients. It's oxygen forged by countless generations of microscopic life. It's carbon the residue of vanished worlds.
Mountains rose and eroded, their dust feeding plains. Rain sculpted valleys, glaciers carved fjords. Lightning split the skies billions of times a year, each bolt writing a brief illumination upon the atmosphere. The planet spun, wobbling slightly on its axis,
processing through cycles that marked the rhythm of ice ages and interglacials. Even the moon, that steadfast companion, receded farther each year, its face forever locked toward us, yet inching away, altering tides that had once roared across continents. Deep beneath the crust, crystals grew at atomic patience, and within them, tiny bubbles of ancient air lay trapped, the breath of worlds long vanished. Scientists would one day drill into polar ice to read these records, to see in layers of frost the pulse of the planet's lungs. They would learn that climate has never stood still, that balance on Earth is not stasis, but rhythm, the oscillation of heat and cold, of bloom and decay. And still the planet spins. In deserts, grains of sand trace the memory of vanished seas. In mountain caves, stalactites count the centuries with their dripping calcium clocks. Every stone, every river, every gust of wind carries the whisper of deep time, the truth that this world has died and been reborn countless times, each rebirth carrying forward the echoes of what came before. As the last great glaciers withdrew and the bones of mammoths bleached beneath thawing skies, the earth entered a gentler rhythm. Yet beneath that calm, its heart still pulsed with molten patience. Humanity multiplied, spread and settled where river met sea, where fertile silt promised the continuity of grain. The first cities rose from mud and sun-baked brick, Uruk shimmering on the plains of Mesopotamia, Memphis reflected in the Nile, the cities of the Indus humming beside monsoon waters. Each believed itself eternal, yet every wall they raised stood upon strata that had once lain beneath oceans older than memory. The people of those valleys read the heavens and carved calendars into stone, not knowing they were tuning themselves to the same celestial mechanics that once froze and thawed the world. They watched the sun climb and fall, measured the flood, honored the moon that tugged the tides, but they could not see that the ground beneath them drifted. The continents that carried their empires were not fixed, but adrift on currents of rock, moving inches each year, rearranging the face of the planet as surely as wind rearranges sand. When the priests of Babylon charted Venus, when the Maya etched their cycles into stelae, when the Chinese astronomers recorded comets, they were, unknowingly, witnessing the same cosmic order that had birthed the world itself. Earth was never silent. Beneath the Mediterranean, slabs of oceanic crust plunged into the mantle, birthing the volcanoes of Italy and Greece, their smoke rising like oracles. In the Pacific, subduction zones arced into chains of fire. Japan, the Philippines, the Aleutians, all children of that burning edge. The planet spoke in earthquakes and eruptions, in ash and lava, in the slow uplift of ridges that once slumbered beneath water. Its voice was long misunderstood, its tempests attributed to gods and monsters. Yet each tremor,
Each plume, each geyser was simply the exhalation of a living world maintaining its balance between heat within and cold without. As centuries turned, humanity learned to read more of the planet's script. Alchemists became chemists, stargazers became astronomers. Sailors traced currents and winds that circled the globe like veins. The age of exploration revealed that the world was round not only in theory, but in horizon. Its oceans joined, its climates interconnected. The magnetic needle that guided ships was drawn by that hidden dynamo in the core, the same invisible engine that had protected life from the sun's fury since the planet's youth. Every compass stroke was a conversation between iron in a sailor's hand and iron spinning at the planet's center. Mountains, once seen as immovable, began to yield their secrets. Fossils of seashells high in the Alps told of uplift, of crust forced skyward by unimaginable pressure. In coal seams of England, the ghosts of ancient forests revealed themselves. In amber, insects from Cretaceous dawn lay trapped as if time had paused for them alone. By the 18th century, scholars like James Hutton began to perceive the immensity of geological time, a deep time in which whole continents could rise, erode, and rise again before the span of human history had even opened its eyes. When the Industrial Age dawned, humanity tapped into Earth's buried memories. Coal from the Carboniferous, oil from the Jurassic, gas from the Cretaceous, fuels distilled by the planet's patient chemistry. With every ton of carbon burned, the breath of ancient ferns returned to the air, altering the delicate composition that life had taken eons to refine. The atmosphere thickened with the exhalations of industry, and the planet, ever responsive, began to adjust its climate in return. Steamships crossed oceans once navigated by stars. Rails stitched continents. Telegraph wires carried pulses of electricity faster than wind. Yet beneath this hum of progress, volcanoes still erupted, glaciers still carved valleys, and the planet's orbit continued its slow oscillations. The same cosmic choreography that once guided the ice ages still governed the rhythm of seasons and tides. Humanity's triumph was vast but temporary. It did not escape the laws of its birthplace. In the 19th century, a new revolution unfolded, not of machines, but of understanding. Geologists mapped strata like librarians of eternity. Charles Lyell declared the present to be the key to the past. Darwin, sailing on the Beagle, saw in coral reefs and Galapagos finches the fingerprints of evolution etched across landscapes. Earth was no longer a static stage, it was a protagonist, shaping and reshaping the possibilities of life through catastrophe and calm alike.
Meanwhile, scientists measured the age of rocks using the decay of uranium into lead, unlocking clocks that ticked in atoms instead of sand. The numbers they revealed were staggering. Billions of years, not thousands. The human story became a brief flicker in a cosmic narrative far older and grander than myth had dared to imagine. In laboratories, the composition of air was deciphered, oxygen and nitrogen as before, but with trace gases that told deeper tales: argon, neon, carbon dioxide, methane. Meteorologists charted winds that circled the globe like arteries of heat. Oceanographers mapped currents that conveyed energy from equator to pole, linking climates like organs in a single body. Slowly, the awareness dawned that Earth was not merely the ground beneath us. It was a self-regulating system, a symphony of geology, chemistry, biology, and atmosphere intertwined. In the 20th century, seismographs listening to earthquakes revealed the planet's layered structure in echoes. They heard the crust's brittle crack, the mantle's rolling murmur, the liquid core's reverberation, and the solid inner core's subtle ring. From these whispers emerged the first clear image of Earth's anatomy. Plate tectonics, once dismissed as speculation, became accepted truth. Continents drift because the lithosphere rides upon convective cells in the mantle. Mountains rise where plates collide. Rifts open where they part. And volcanoes mark the points where Earth releases its inner heat. The discovery reshaped everything. The Himalayas were no longer mysterious walls, but the scar of India's collision with Asia. The Andes were the result of an oceanic plate plunging beneath a continent. The mid-Atlantic ridge became proof of continuous creation, new crust forming as old crust sank elsewhere. The surface of the Earth was no more permanent than the clouds above it. Yet even as the maps changed, the planet's deep memory remained. In Greenland's ice, scientists drilled cores that captured 1,000,000 years of snowfall, each layer preserving the atmosphere of its season. Tiny bubbles told of temperatures, dust, and greenhouse gases. They spoke of warm periods when forests reached the Arctic, of frozen ages when ice blanketed continents. They showed that climate had always danced in cycles, driven by orbital variations, eccentricity, tilt, and precession, but that now the tempo was quickening, the amplitude growing. Humanity had become a geological force. Still, Earth endured as it always had, responding to perturbation with feedback and flux. Volcanoes emitted sulfur that cooled the skies. Forests absorbed carbon. Oceans breathed in and out with the changing heat. The biosphere and the geosphere remained partners in an ancient dialogue. Even the smallest plankton, drifting in the upper sunlit ocean, played its part, drawing carbon into shells that, upon their death, rained down as chalk to the seafloor, building cliffs that would one day overlook human harbors. From orbit, astronauts later beheld the whole planet at once, a blue marble veined with white, suspended in darkness. They saw in its thin atmosphere the fragility of everything known. They realized that continents and nations were illusions of perspective, that all boundaries faded where clouds moved freely. Their photographs became icons not of conquest, but of recognition. Earth as a single breathing entity.
And still, the planet changed. Earthquakes in the Pacific reconfigured coastlines overnight. Glaciers in the north retreated, revealing valleys untouched since mammoths. Deserts advanced across continents where monsoons once fell. Beneath the oceans, black smokers vented mineral-rich plumes that sustained entire ecosystems without sunlight. Proof that life's tenacity was not confined to the familiar. In the upper atmosphere, auroras rippled where solar particles met magnetic fields, reminders of the shield that guarded all beneath. Across the deep interior, radioactive decay continued to power the geodynamo. Convection cells rose and sank. Islands were born and swallowed. The continents, slowly drifting, moved toward a new configuration, a future supercontinent, perhaps, 100 million years hence, whose outlines exist already in models and imagination. Earth has not finished rearranging its face. It never will while its core still burns. And humanity, now numbering billions, has begun to sense its own smallness against that vast living time. Sensors in orbit track storms and currents. Observatories record the shimmer of auroras from pole to pole. Probes descend into ocean trenches where pressure would crush steel. Each measurement adds a line to the biography of the planet, a biography still being written in the languages of physics and wonder alike. By the close of the 20th century, the Earth had begun to reveal itself not merely as a sphere of rock and water, but as an organism of interwoven systems, a dynamic equilibrium in which every element influences the next. The study of climate became the study of the planet's heartbeat. Satellites traced the motion of clouds, the bloom of plankton, the shimmer of polar auroras. Data replaced prophecy, yet wonder endured. The biosphere pulsed in cycles of breath and silence, each leaf and ocean wave participating in the grand respiration of the world. In laboratories, scientists measured isotopes that told stories older than continents. They discovered that oxygen itself bore subtle variations depending on the temperature of the sea that produced it. From coral skeletons,
They reconstructed vanished summers. From the pollen in ancient lake beds, they saw forests advancing and retreating like slow tides of green. The planet's memory proved infinite, hidden in every molecule. Humanity had learned to listen, though not always to heed. Volcanoes continued their ancient testimony. When Mount St. Helens erupted in 1980, when Pinatubo darkened skies in 1991, they reminded humankind that all industry was dwarfed by a single sigh of the planet's crust. The ash that circled the globe cooled temperatures for years, scattering sunlight into crimson twilights that painted evening skies from Manila to Madrid. Such events were the punctuation marks in Earth's long sentence, brief, violent clarifications of its living presence.
Beneath the oceans, the tectonic ridges continued their slow exhalation of basalt. The mid-Atlantic ridge extended from Iceland to the southern seas, splitting at a pace of a few centimeters each year, yet across eons it had widened an entire ocean. In Iceland's rift valleys, one could stand with one foot on North America and the other on Eurasia, feeling in silence the planet's slow division. No clock could measure such patience. As the century turned, new eyes gazed inward from space probes that had once looked outward. Instruments designed for distant planets now studied our own atmosphere, searching for the same spectral signatures of life that astronomers hoped to find elsewhere. The result was humbling. Earth's chemistry was rare, precarious, self-maintaining. Its thin film of air, barely a veil compared to its size, was the difference between silence and song. Within it, temperature, pressure, and composition had remained in delicate balance for hundreds of millions of years, held there by feedbacks subtle as breath. Yet, the scale of human transformation accelerated. Cities sprawled like luminous constellations upon the night side of orbiting photographs. Rivers were dammed, forests felled, wetlands drained. Carbon, once sequestered in stone and coal, flowed again into the air, its infrared signature detectable from space. Climate models began to predict futures once reserved for myth: rising seas, melting ice, the shifting belts of wind that defined the temperate zones. And still the Earth responded, not in anger, but in accordance with physics. Warming oceans, expanding air, migrating storms. But even these upheavals were but episodes in the greater chronicle, for the planet had endured worse. Volcanic winters that blotted out the sun, asteroid impacts that vaporized oceans, ice ages that buried continents. What distinguished this new epoch was not the magnitude of change, but its source. Never before had a single species become a geological force, altering the composition of the atmosphere as profoundly as the cyanobacteria of the Archean. The Anthropocene, scientists began to call it, the age of human influence, the continuation of Earth's own evolutionary narrative through the mind of one of its creatures. Deep within mountain caves, stalagmites recorded the chemistry of rainfall over tens of millennia. In their calcium layers, the signatures of lead and carbon traced the rise of metallurgy and industry. Even the sediments at the bottoms of remote lakes carried traces of synthetic compounds, polymers, and radionuclides, signals of a species that had learned to rearrange matter at will. The rocks of the future would bear its fingerprints. Yet, amid these transformations, the planet's deeper rhythms persisted. The rotation of Earth continued to slow by milliseconds each century as the moon's pull drained its spin. Tides still swept coastlines twice a day, sculpting deltas and estuaries. The magnetic field, ever restless, wandered toward Siberia, preparing perhaps for another reversal, a phenomenon that had occurred many times before, leaving basaltic stripes across the ocean floor. As testimony, life, as always, adapted. Migrating birds altered routes to follow shifting climates. Coral species sought cooler waters. Forests crept poleward, seed by seed. And through it all, the human gaze turned outward again. From the vantage of Mars orbiters and lunar telescopes, Earth appeared as a luminous point of color, blue, white, and tan, its weather visible as momentary swirls, its continents recognizable at a glance. Astronomers realized that from light alone, one could tell a world was alive. The reflection of chlorophyll, the absorption of oxygen, the dance of water vapor. In seeking other Earths, they learned to appreciate the singularity of this one.
The sciences of geology and biology merged into a planetary perspective. Researchers traced the carbon cycle through volcanic vents and root hairs, through oceans and atmosphere, through shell and soil and cloud. They saw how the subtlest balance of gases allowed liquid water to persist, how the planet's distance from the sun, neither too close nor too far, kept it within the narrow band of habitability. The coincidence of size, magnetism, and composition was profound. A slightly smaller core and the magnetic shield would fail. A slightly greater distance and oceans would freeze. Every condition was a gift of cosmic precision, the result of billions of random interactions playing out under the governance of gravity and time. In the depths of the ocean, explorers discovered ecosystems entirely detached from sunlight, thriving on chemical energy from hydrothermal vents. Tube worms, blind shrimp, and bacterial mats flourished where superheated water met freezing abyss. It was as though the planet whispered a reminder: life does not depend upon the sky alone. From those vents, scientists imagined worlds beneath the icy crusts of Europa or Enceladus, echoes of Earth's earliest days. Meanwhile, on the surface, the record of the past continued to surface in unexpected forms. Meteorites revealed fragments of the primordial solar system, their isotopes carrying the same elemental ratios as Earth's mantle. Zircon crystals, the oldest solids on the planet, told of oceans existing 4 billion years ago, when the sun was faint and the atmosphere thick
with carbon dioxide. The faint young sun paradox, once a puzzle, became a testament to feedbacks that kept water liquid despite lesser light. A hint of the self-adjusting mechanisms that made Earth unique among its neighbors. And still, continents drifted. The Atlantic widened, the Pacific narrowed. Australia crept northward toward Asia. California slid along its fault lines like a restless raft. Earthquakes marked their progress, each a reminder that solidity is illusion. Even mountains, symbols of permanence, are temporary, gestures in the dance of plates. The Himalayas grow higher each year, even as monsoon rains gnaw them down grain by grain, a balance of uplift and erosion that defines the pulse of the planet. The biosphere, too, is a product of tectonics. The position of continents dictates ocean currents. Currents govern climate. Climate shapes evolution. The closing of the Isthmus of Panama once diverted currents and triggered glaciations. The rifting of Africa birthed lakes that became cradles for early humans. Every landscape is both consequence and cause, sculptor and sculpture at once. In the 21st century, instruments orbiting far above now monitor these processes in real time. Gravitational sensors measuring the redistribution of water. Spectrometers tracing the faint breath of photosynthesis across continents. Radar mapping the slow rise of magma beneath volcanic arcs. Never before has the planet been so thoroughly observed, and yet its essence remains elusive. No equation captures the aesthetic of sunrise on dust, or the scent of petrichor after rain, or the quiet resilience of moss upon stone.
As knowledge deepens, humility follows. We learn that Earth's stability is the product of ceaseless motion, that equilibrium is achieved only through change. The magnetic poles will shift again, continents will fuse, oceans will disappear and reappear. New mountains will rise where plains now lie. In 500 million years, the sun will brighten, perhaps too much for oceans to endure. Long before that, life will adapt or perish, as it always has, folding its story into the strata for whatever consciousness may one day read it. Even so, the present moment, our moment, is extraordinary. A planet alive in every layer, conscious of itself through the species that names it. From magma to mind, from hydrogen to thought, the arc of Earth's history is one of transformation without rest. The same elements forged in the hearts of ancient stars now compose the neurons that contemplate them. Every breath drawn is a continuation of that first oxidation in Precambrian seas. Every heartbeat echoes the rhythm of tides established when the moon was young. And as night falls over the turning world, the planet glows faintly in infrared, radiating the heat it receives from the sun back into space. It is a quiet exchange, a conversation of energy that has lasted for eons. High above, auroras flicker where solar particles meet magnetic field lines. Deep below, the core hums with convection. Between those boundaries of fire and frost, life persists, restless, fragile, and magnificent. Even now, as the 21st century lengthens into the unknown, Earth remains both ancient and newborn. Its continents drift at the speed of fingernails, but their collisions raise mountains that will outlast languages. Beneath the crust, magma chambers pulse like hidden hearts. Above, the atmosphere swirls in ever-changing spirals of moisture and dust. Every sunrise is an intersection of countless cycles, the rotation that began when the planet was still molten, the orbit inherited from the protoplanetary disk, the tilt that grants us seasons, the procession of equinoxes that reshapes calendars across ages. In this moment, the biosphere vibrates with unprecedented diversity. 10 million species known and unknown, each a distinct experiment in the chemistry of survival. From bacteria colonizing Antarctic ice to fungi threading through Amazon soil, from whales navigating magnetic gradients to seeds that sleep for centuries in desert sand, life continues its dialogue with matter and energy. Evolution, far from finished, hums in every genome, recording adaptation like music engraved upon spirals of DNA. The oceans, vast beyond imagination, act as the lungs and memory of the planet. Their currents store heat, their depths absorb carbon, their plankton bloom in synchronized waves that sustain the chain of existence. Within those depths lie mountain ranges higher than the Himalayas, trenches that could swallow Everest whole, creatures whose light pierces darkness untouched by the sun. Hydrothermal vents vent whispering clouds of minerals, forming metal-rich towers that gleam in the glow of bacterial fire. Each vent is a mirror of the planet's origin, a reminder that creation has never ceased.
Above the waves, winds trace invisible highways around the globe. The Hadley cells rising near the equator, the jet streams racing at 10 kilometers height, the monsoons breathing in and out with the migration of heat. In every storm, energy cascades through scales, from the convective eddy to the hurricane's eye, following laws older than continents. Lightning splits nitrogen, feeding soil. Thunder echoes the charge that once animated primordial chemistry. Rain falls, rivers gather, deltas fan into seas, sediments settle to become tomorrow's stone. Within the crust, minerals grow and transform under pressure unimaginable. In subduction zones, slabs of ocean floor descend, releasing water that triggers volcanism. Above them, arcs of islands mark the borders of fire. Deep in cratons, diamonds crystallize over billions of years, each atom aligned in perfect lattice, each gem a fragment of Earth's earliest heartbeat. To hold such a fragment
is to bridge cosmic and terrestrial time. The magnetic field flickers and drifts. Auroral ovals widen and contract as the solar wind strengthens and wanes. During geomagnetic storms, power grids tremble and satellites blink, yet the spectacle of green and crimson light above the poles reminds all who see it that beauty and danger are woven from the same plasma threads. Without that magnetosphere, the upper atmosphere would erode, water would escape to space, and the planet would become as barren as Mars. The dance of charged particles across night skies is more than a spectacle. It is survival made visible. In deserts, erosion etches calligraphy upon stone, revealing layers that read like pages. Fossil dunes hardened into sandstone, ripple marks from vanished seas, ash beds marking ancient eruptions. Each stratum tells of climates forgotten by memory, but preserved in mineral language. The Sahara once hosted hippos and herds. Antarctica once bore forests of ferns. Greenland's buried soils recall flowers beneath ice 1,000,000 years old. Time does not erase, it layers. The future will add its own lines, perhaps recording our species in thin bands of concrete dust and microplastic, a horizon recognizable to geologists of whatever life succeeds us.
Beyond the biosphere, Earth moves through space encircled by artifacts of its children. Satellites, debris, silent relics drifting in the same gravitational embrace. From those instruments come images of hurricanes spinning like galaxies, of auroras like emerald veils, of night continents outlined in light. They form the first true mirror humanity has ever held to its home. For the first time, a species can watch continental drift, glacier retreat, and forest regrowth unfold within its own lifetime. Awareness itself becomes a geological agent. Yet the deeper truth remains. Earth is not separate from the cosmos that birthed it. The same gravitational tides that stir its oceans also shift the orbits of moons. The same cosmic rays that seed clouds also mutate DNA. The same interstellar dust that darkens starlight settles upon our snow. The planet is porous to the universe. Meteorites deliver amino acids. Solar radiation drives weather. The galactic environment modulates climate across eons. To study Earth is to study everything. Still, among all worlds known, none other shows this mingling of fire and water, stone and soul. Mercury is a scarred ember, Venus a furnace of carbon and cloud, Mars a frozen memory of what might have been. Beyond them, gas giants whirl in perpetual storm, their moons bearing hints of subsurface seas, but no forests, no voices, no laughter. Only here do tectonics, magnetism, atmosphere, and life form a closed circle of renewal. The rarity of that coincidence humbles the mind and elevates it at once. If one could compress the entire history of Earth into a single year, January would see its formation from dust. In March, the first oceans would condense. In May, life would appear. In October, oxygen would bloom. In November, multicellular creatures would arise. The dinosaurs would rule for a week in December, vanishing on the 26th. Humanity would arrive in the final minutes before midnight on New Year's Eve. Agriculture in the last few seconds. The Industrial Revolution in the blink of an eye. The metaphor is crude, but instructive. The world's grandeur is not ours to own, but to witness. And yet, the witnessing itself is part of the planet's evolution. Consciousness has become geology's newest frontier, a force that maps and models the very system that sustains it. Through language and mathematics, humans extend Earth's perception beyond instinct, turning reflection into a planetary function. The study of plate tectonics, climate feedbacks, and orbital dynamics is not separate from nature. It is nature aware of itself. The equations written on whiteboards are the murmurs of matter contemplating its own origin. In caves where prehistoric painters once drew bison and hands, moisture still condenses on limestone walls, and carbon from their torches mingles with modern air. Those pigments are older than many civilizations, yet young compared to the stone beneath them. They remind us that to record is to participate in time, to fix one moment within the continuum. Every story told about Earth, every map, every measurement is an act of communion with the planet's unfolding.
And so the narrative continues. Glaciers will come again. Continents will merge into another supercontinent. Species will rise and fade. The sun will brighten until oceans boil away. The atmosphere will thin, and in the distant dusk of its orbit, Earth will perhaps shed its mantle to space, leaving behind a cold core circling a dim red star. But before that final transformation, countless epochs of beauty remain. The blooming of future forests, the migration of future life, the silent drift of mountains across the horizon of millennia. Even in that remote future, traces of today will persist. The radio waves we send, the fossils of our architecture, the isotopic scars of our industry will linger in stone and starlight. The Earth will remember as it has always remembered, in chemistry and motion rather than in words. And if another intelligence one day finds it, turning some distant telescope toward the fading blue of our world, they will see what we see now, a sphere alive with clouds and color, balanced between fire and frost, still singing the same elemental song it began billions of years ago. The earth turns once more. Somewhere dawn spills across deserts. Somewhere night folds over forests. Waves strike cliffs carved by ancestors long gone. The air, shaped by the breath of ancient algae, moves through lungs and leaves alike. In that circulation lies the unbroken continuity of everything that has ever lived here, from the first cell to the last whisper of wind. The earth endures, not as background to history, but as history itself, an endless, self-writing epic whose chapters are written in rock, water, and light, and whose voice is the slow, ceaseless rhythm of existence.